Okay, welcome to our Friday session, or perjantai precis, as we call it in Finnish. Today we are talking about DevOps, cloud, I assume, Kubernetes and stuff. Our guests are from UpCloud, so please welcome Ville and Mikael.
Thank you very much, Jonas. It's a pleasure to be here. Nice to see that so many have showed up, although it's sunny and almost weekend. I appreciate that there's a lot of people wanting to listen to us. I'll just introduce very shortly first myself and then UpCloud as a company. I'm not sure if everybody here has heard about us. And then I'll let Ville take over and talk about the actual topic of today, which is Crossplane. So we're going to run into that very, very soon. UpCloud, as hopefully most of you know, is a Finnish cloud provider, and these are sort of the main messages that we want to bring to our customers, is that we are a trusted cloud partner and have been working with Fractio for multiple years with multiple mutual customers. What we're known for is really a reliable infrastructure. We actually offer our customers 100% SLA from a commercial standpoint, which is quite uncommon in the marketplace today. We know that technically there might be challenges, but we are confident enough to actually go out with that bold statement. So that's one thing that people know us for. Secondly, we are very proud about how we handle our customers, and also customers seem to be liking the way that we work with them. 24/7 support globally is offered by UpCloud with a response time of less than 2 minutes. Again, something that's not very common in the cloud space, so something we're proud about. I'm going to talk a bit more about pricing on a second slide here, but that's of course a big part of a lot of our customers' worries, is that their cloud spend is going through the roof, and we believe that we have a good solution also from a commercial standpoint to our customers. So we definitely want to sort of take the chance here to talk to both Fractio and Fractio customers and other people out there listening to the webcast here to make sure that you know who we are and what we do. And the theme of today really will be around Kubernetes, and some of you might have heard that we launched Kubernetes, a managed Kubernetes service of our own last spring. We've been continuously building upon that, and now recently also added Crossplane as a supported feature, so that's going to be something that Ville will be talking about more in a second. Just to show you where in the world we are situated, as hopefully most of you know, we have our headquarters here in Helsinki. We have another office in Singapore, but we've got 13 DCs around the world, 8 of which are in Europe. So we are a global player, although we are still sort of small in the cloud space compared to some of our bigger competitors, especially the big three that everybody knows. Two things I wanted to mention before I give over to Ville in terms of why people actually turn to UpCloud instead of perhaps the hyperscalers that everybody knows. One key thing that our customers look at is that if they have requirements of EU data regulations and data sovereignty, we're a good fit in that sense that we are a Finnish company, totally owned by Finns as well. So we follow EU law, and with data centers physically here in Finland and around Europe, we can offer a GDPR compliant solution to the most sort of demanding customers from that point of view. So that's one space where we are a really good fit and where we can compete with the big three and the Americans, giving an European alternative to the Americans. A second space where we know that we are really competitive is on pricing. So a lot of people ask how's that possible, but essentially with open source platform and building our own solution, that we can keep prices in check. And of course, price performance ratio is something that's really important to us. So that's something that we've been investing heavily in over the last few years. But on average, if you look at a specific workload that's put on UpCloud compared to, for example, AWS, Azure, or Google, we are around 30 to 60% more affordable than our American competitors. So again, something that's very important, and especially for our sort of target audience, which is smaller and mid-sized companies that are growing and they see a growing need for cloud, then we can keep those cloud spend in check. So with that, that's a very short intro about who UpCloud is and what we do. I'll be around and you can come and ask more if you want to afterwards, but I'll introduce Ville, who is part of our Kubernetes team, and he's going to be here talking about Crossplane to give you more insight into some of the latest developments that we've added to our feature stack. So Ville, please.
Thank you, Mikael. So my name is Ville Välimäki. I work for UpCloud, as you probably guessed. I've been in the developer experience team during the past few months. So my work mostly consists of developing and improving the user experience of UpCloud customers, and that includes developing our Terraform provider and CLI tooling and other measures that people would use to provision UpCloud services for their own usage. I'm going to share a little bit of my own background so you can kind of have more insight where my kind of view on Crossplane comes from and why I'm bringing up these points that I'm bringing up here. So I've been in the software business around 12 years now, and in my history I've been mostly doing in-house product development, so it's been interesting journey from VMware host virtual machines and then self-managed Kubernetes clusters to serverless functions. So I've been involved in the stack from the ground up to the end user experience. So I kind of enjoy working with the customer experience and developer experience that we have here in our team in UpCloud. So yeah, that's enough about me. Let's continue on the actual topic. So here I'm showing a bit what we are going to talk about today. I've divided the session into two main sections. So first we're going to approach the theory part and maybe try to get a grasp of what Crossplane actually is. How does it compare to some of the other alternatives that are out there, and what can you actually do with Crossplane? And then in the end of the session we're going to take a brief look on a real-life example on how to use Crossplane to streamline a developer operations process. And regarding that, we're going to take a look at different themes that Crossplane provides us and go through them in a pretty practical way. So first of all, I would like to kind of open up my personal view of cloud orchestration. There are many definitions of the term, what does it actually mean, but what resonates with me is this. So I consider it to be automating the provisioning of infrastructure and the deploying of workloads and access management. Of course, there are other things that are included, but these are the main points that I see fit. Cloud orchestration can be done on public, private, and hybrid clouds, depending on your business case and needs. Usually, the tools or scripts or manual interactions are with the APIs of the service providers or something like VMware hosts. And it can be done using either imperative or declarative methods, depending on the phase where you're at. For example, in the beginning of setting up a new infra, you might want to stick to an imperative method, and then afterwards provision some stuff on top of that with declarative methods. Okay. Then the actual mysterious Crossplane. What is it and why are we here today? This is a direct quote from Crossplane's website. So it's an open source Kubernetes extension that transforms your Kubernetes cluster into a universal control plane. It's open source project built originally by UpBound, which is not to be confused with UpCloud. It's pretty similar, but yeah, we're not affiliated yet, at least. Let's see. We're trying to collaborate with them, of course, now that we're building our own Crossplane provider. It's a cloud-native computing foundation project in incubation phase. With Crossplane, you can orchestrate infra across different cloud providers. So, in a sense, it's a tool that you can use to manage various providers at once. And if there is an API available, then you can build a Crossplane provider on top of that. The thing where Crossplane tries to shine is that you can use familiar Kubernetes constructs to manage all your infra. So it's not needed to kind of get along with a new configuration language or find out how a new SDK works, but you actually already have most likely tool set available if you're looking at Crossplane, because you might have a suitable cluster to run it in. One of the most important selling points for me is to create the availability of creating reusable compositions of managed resources. So basically, there can be compositions or other methods for developers that they can provision themselves and manage. And these could also cater for some automation needs. Let's say you have a workflow where you need to set up an application test environment. So it's pretty convenient to recreate these things using compositions on Crossplane. And it's a method of composing different managed resources together, and then you can actually give a developer or a script permissions to execute that and provision stuff in the cloud. So what basically happens with Crossplane is that end users, in this case we would consider end users to be developers or maybe platform engineers who are actually responsible for the whole infra. So they are interacting with the Kubernetes API, and they are using pretty standard Kubernetes tools that you can find in any tutorial or any startup guide for Kubernetes. So kubectl, Helm, any other tool that you might want to interact with Kubernetes with. So basically, like I mentioned before, this is one of the selling points that Crossplane has. It's kind of easy to get started with if you are already working with Kubernetes. And you might be able to grasp the inner workings of Crossplane pretty easily if you're familiar with the whole Kubernetes scene. And another view on that is that the end users might have different profiles. There might be developers, like I mentioned, and they don't have to actually know what happens under the roof, but it's kind of interesting in a sense that you can use it in many ways. But interaction is pretty easy, like just applying a YAML file and off you go. Crossplane sits in a Kubernetes cluster, so you install it to a cluster, and that I would call like a management cluster that allows you to manage different kind of resources. They could be service provider resources or something else that we will look a bit more in the later phase. But basically, it's a requirement to have a cluster already in place for Crossplane. There are ways to circumvent this, of course, so you can create a bootstrap cluster and then install Crossplane there, and then there is a way for Crossplane to manage the cluster it's in itself as well, but that might be an approach that is not the most common. Once you have Crossplane in the cluster, using the controller pattern, it will provision any managed resource a user requests. So it will use a provider to provision any resource that we want. Here is an image of the overall architecture of Crossplane. So what we have here on the left side, we have the interactions, and they are with the Kubernetes API, either with CLI tools, client libraries. You could even have a graphical user interface for Kubernetes API. That's a pretty common way to manage it as well. And then on the actual Crossplane section, you can see that we have resource controllers that actually interact with third-party service providers, like cloud providers. You can see there's UpCloud, Google Cloud, Azure, AWS, and of course other possibilities are available as well. There are many tools to kind of work with the cloud, and I have put up here a short comparison based on my own views, and I will try to explain these in a bit further detail. So basically first we have Crossplane, and on Crossplane, like mentioned, the client and the user would interact with the Kubernetes API. And if we move right to Terraform, which might be a familiar tool for many of you, the client would directly interact with the service provider API. This can be done, of course, from a local machine if you're testing stuff out, or if you're one person shop, but that's not maybe a production quality way to work. So in that case, you would maybe have a CI/CD pipeline that would run the Terraform commands, print out the plan, and then do the apply if everything looks good. So the difference here is that the client, in this case the Terraform client, would need to have already enough permissions to interact with the service provider API. Let's say I want to spin up a test database or a test Kubernetes cluster. The client needs to have permissions to do that, and you have to store those credentials somewhere and do the secrets management for that naturally. So it's kind of a different approach when it comes to Crossplane. So in Crossplane we have a user that can apply abstractions in the cluster. So let's again take the example of a developer who wants to provision something alongside his workload, let's say some kind of object storage like a S3 compatible bucket or whatever. He needs to, or she needs to store stuff there. What he actually needs as a authorization is just role-based access control to the cluster abstraction that's in the cluster. So Crossplane abstraction stays in the cluster, and the developer has permissions to create a new resource by applying a claim or composite resource in the cluster. So there is no interaction directly between the user and the service provider API. We'll get back to that in a bit. One thing that also is pretty different in the Crossplane world from Terraform and other tools, in my point of view, is that the state that you have stored for your infra might be, well, the actual state might be different than the desired state. So basically what might happen is that some person would go on to the UI of the service provider, web UI for example, and change something on the cloud, any service that is provisioned there, and then the desired state would not match the actual state anymore. Or if there is an outage of some kind or something else happens. In the Terraform world, you would need to reapply the whole configuration you have, where the resource is defined, and then you would get an informational message that there has been some drift between the actual state and the desired state. Somebody has done something has changed. But this always has to be done, maybe not manually, but in some kind of automated fashion, where you actually have to schedule the run, or you have to maybe do a trigger that would do the run in the CI/CD pipeline or something else. So there is no straightforward mechanism to do that. On the Crossplane, on the other hand, as we are using the controller pattern on Kubernetes, so there are controllers for each resource type, and they are doing the reconciliation loop to manage the drift. Basically, what happens by every given time frame, the controller would go and check if there is any difference between the state that's actual in the cloud or between the state that we have desired the resource to be in. So basically, we are able to leave all that responsibility to Crossplane and the Kubernetes mechanisms to keep the infra as it's supposed to be. And regarding the state, Crossplane stores the state in fairly standard Kubernetes fashion in etcd, and that's also, of course, a thing that needs to be backed up if you are serious about your production resources, but that can be done in a very standard way. How would you back up etcd in any case? So Crossplane doesn't kind of bring anything new to the table in that sense. On Terraform, you have to have some kind of backend for the state, and that's where it's managed. It can be either a S3 compatible bucket or HTTP backend or even Terraform Cloud. But basically, that's something you have to consider separately. What we haven't talked about yet are the so-called other tools that are there on the right side. So there are, of course, many ways to interact with cloud service providers. There are things like Pulumi, CDKs, and different kind of SDKs, and CLI tools that you can use to interact with cloud providers. Basically, on this comparison, they align quite a lot with Terraform, on the sense that how we interact with the API, how does the client interact with the API, what's happening behind the scenes. So basically these tools take user input and send it to the API quite directly. One pro that I could kind of mention here about some of the other tools is that you might be able to write code in a programming language to provision your infra. So then you might get rid of YAML or HCL, which might be a plus for some, I don't know. Okay, so now we have talked a little bit about Crossplane. I'm pretty sure it's not totally clear what it is yet and what can you do with it actually, but I hope the following real-life example will give you some insight into that. But first, let's take a look at what kind of providers we have available for Crossplane. So basically, all the providers are listed in UpBound marketplace. There are also some pre-made configurations which act like templates for your usage. If you have a special use case that's been considered as a pretty standard way of doing things, some of the providers have supplied pre-made configurations for some use cases. I've listed here some examples. So you can find all the major cloud providers, including UpCloud, in the UpBound marketplace. Then you can find also services that provide you different kind of tooling around Git. So Bitbucket, GitHub, GitLab, they also have their providers for you to interact with them and their APIs through Crossplane. Then there are some other tools like Kafka, OpenSearch, Postgres. So you can command these services through Crossplane as well if you want to do that. If you have a use case for this, it's fairly easy to do. It doesn't really matter if the provider is a cloud provider or if it's a Postgres provider, you interact with it in a similar fashion. And the last one I want to mention is a Spotify provider. So you can manage your Spotify playlists with Crossplane provider if you want to add Kubernetes to that mix. Okay. So here I have some kind of user story that we're going to take a look at now. Let's assume that I'm a developer and I want to provision a managed database alongside my Kubernetes workload. I could do that with Terraform and then somehow copy-paste the connection strings and other stuff that's needed to actually interact with the database. Or I could use Crossplane. Let's see what is the problem here from the platform team's perspective. So the platform team would like to enable developers to provision managed databases by themselves, so they don't have to be involved in every step here. But they want to limit the way the developers provision the stuff. They want to control the parameters. So they cannot just give them access to the database endpoint on the cloud service provider. They want to control the usage of the endpoint, so no huge bills will arise. In this case, the developers are already familiar with Kubernetes API. They have been creating typical Kubernetes resources like deployments and secrets for running their workloads. So we have a solution. This is, of course, only one way to solve this problem, but for the sake of this presentation, we can consider that the platform team installs Crossplane to a management Kubernetes cluster, which they already happen to have in place, and allows developers to claim managed resources via Kubernetes API for their workloads. So now we're getting back to the Crossplane terminology. So we have managed resources. Every external service managed by Crossplane maps to a managed resource. In this case, a database would, on a provider, let's say UpCloud, managed database. So that would be considered a managed resource in Crossplane. Then we have compositions. Composition is a template to define how to create resources. And composition can contain multiple different resources, and they can be related to each other. So there can be references by using patch method. So in this case, for example, if we want to create a managed database, but we also need to create a user to the set database, then we can create a composition which contains both, and we reference the managed database service when we create the user. Then we have composite resource definitions, XRDs, which is a custom API specification. This is what the end user interacts with when they want to create something, a resource. They want to provision a resource. So this is a API specification for Kubernetes API. Then there are claims, XRCs, and a claim is something that can be claimed by the end user. So basically, we have XRCs that use the composition template to create new managed resources. So I will explain this in a bit in a graphical way. So these terms might be a bit more clear at that point. And claims are namespace scope. So basically, when a developer wants to create a claim, it's always bound to a namespace in Kubernetes. Then we have composite resources, which are basically the same as claims, but they are cluster scoped, so they are in a broader scope handled in Kubernetes cluster. Okay, so let's take a look here in the starting phase of a Crossplane implementation. Basically, we have here a developer, then we have a platform team, and they have a Kubernetes cluster. What happens next is that platform team installs Crossplane to the cluster, and then they use UpCloud Crossplane provider in the cluster. So UpCloud Crossplane provider then defines managed resources in the cluster, which, like mentioned before, are mapped to the cloud service resources. In this case, it would be a managed database. Then the platform team continues the work and defines compositions and composite resource definitions. In this case, the composition would contain database, instance, and a user. And those map to managed resources by using a reference. Then the developer steps in. Let's say the developer wants to create a managed database in their data namespace that they have access to. So they create a claim, XRC. So then the claim is getting reconciled in Kubernetes, and in the end, a controller that manages the resources defined in the composition that the composite resource definition refers to creates a database and the user via UpCloud API. So basically what happens here is that the provider controllers watch for they are waiting for the claims or composite resources to appear, and then when they appear, they will act accordingly. In this case, they will execute the desired state of the composition using the optional parameters that can be given in the claim or in the composite resource to configure the said resources, like the database zone or something like that. And for the last few minutes, we'll take a look of very simplified examples of these different YAML files that would be created in the cluster. So first of all, we have custom resource definition, and this is something that would be done by the platform team in this example. So we create a composite resource definition which defines here in the last 3 lines. You can see that we are defining claim names. So we are actually creating a claim that can be used by the end users, in this case the developers. So they can claim this. Here we have the open API schema for the composite resource definition. So basically we have 2 properties here. We have the name, which is of type string, then we have zone, which is also a string, and both of those are required properties that need to be set when using the claim. Then the platform team also creates the actual composition. This one is called postgres.xdatabases.platform.team, and here we can see in the spec that we are referencing composite type with kind xdatabase. So basically the previously shown file. What we do here is the most interesting part actually of the interaction with the UpCloud API. So here we create the resources that we want to do using the UpCloud Crossplane provider. So basically, we also require a provider config that's not present here, but it's very similar to Terraform provider config. For example, you need to choose the credentials you want to use, and in Kubernetes world you would store them in a secret in the cluster most likely, or pull them out from somewhere else. What we can see here in the PostgreSQL1 resource, that the kind is managed database PostgreSQL, and in the spec part we are defining the plan. So what happens here is that the plan is already defined on the top level. Well, depends how you consider the view, but on this level, that the platform team actually decides that, okay, we are giving the developers only one type of plan that they can use, so they cannot use any other types of database services with bigger resources. Then in the patches view, we are then using given name and zone to populate the rest of the spec that is needed by the UpCloud Crossplane provider. So we need to have a name and we need to have a zone. And in the last patch, we are pushing the provider, we are pushing the service ID to a status field, so we can reference it in the user creation. So this is pretty much the same. We are using the UpCloud Crossplane provider to create a user for the managed database. We have a fixed name of user1, so the end user cannot change it. And then we have a service ref with a placeholder there, and we are going to patch it with the service ID from the status field. And how all of this comes together from the developer point of view is in a very short basic form here. So we would apply a database claim to a certain namespace, in this case example app, and then we give out name and zone for the database in the spec, which were the two required properties in the custom resource definition. And here we are. Now we have a database and a user in the cloud. Thank you. Do you have questions? I think we have 15 minutes or something like that for further discussion. Yes.
Yeah, so did I understand it correctly that even if, let's say we have the UpCloud provider and it has some definition for how to create like I don't know, a virtual machine, and the developers, they can't just themselves, we can say, hey, create me a virtual machine, and first the platform team needs to like, well, just create like some basic access control or something that, or make a composition that only contains the virtual machine.
Yeah, that's one way to use the crossplane.
Okay.
Yeah. Of course, you can, if you want to give your developers access to directly interact with through the crossplane provider with the service providers, you can of course let them do that. But in a way, in this virtual machine example, you could, for example, add some predefined configuration to all of the virtual machines, so the developers couldn't create them without it. So you could kind of control it a bit more and maybe limit something or do things like that. Anything else?
Yeah, how difficult it is to debug if there's errors, because there's a lot of errors with Terraform state, sometimes with different providers. So has that been difficulties in debugging the state?
It can be a bit difficult, but as we are using the pretty standard way of Kubernetes controllers and control pattern, you should be able, depending on the output of the providers, of course, you might get some good logs there, but it's also possible that it can be a bit difficult. But I've also experienced quite a lot of difficulties when debugging Terraform state errors.
Because it's quite difficult to debug Terraform state issues. So
Yeah,
at least with huge state files. So.
yeah, that's an issue. And I think many of the things when compared to Terraform, Crossplane compositions would kind of map to Terraform modules in a way that you can create a set of things that people can then just easily provision. But also there the state management is a bit different. When you create modules, then it's not so straightforward in Terraform to manage the states of the different modules and how they interact with each other. So that's kind of one way to look at it and one way to see the differences between Crossplane and Terraform. You had a question there.
Yeah, it's about this. We are more familiar with Terraform, I guess. So what are your favorite best features Crossplane over Terraform? What are the best things? Your personal favorites?
My personal favorite is the reconciliation loop, which has happened to me quite many times that for some reason or another, something has changed in the actual state of some service or resource in the cloud. Either somebody has modified it manually or even by purpose. You have to make some temporary change and then you forget to turn it back. And then you only realize the fact when you're running the Terraform CI/CD pipeline again. You notice that, okay, this thing has been messed up for a while because I haven't been rerunning the apply just to check the things. So with Crossplane, it just goes there and fixes it back to the desired state. That's what I really like it and like about it. And also, well, you can say a lot of things about YAML, but it's a nice way to put all of your things in the same fashion when you deploy your workloads and provision your infra with very similar YAML files, Kubernetes tooling. So that's kind of a plus to me. So you don't have to constantly be changing your mindset on that. You have more questions, right?
Yeah, you said that people often don't, import their cluster that Crossplane is running on into the Crossplane state management. It's like, is there some decent like pros or cons to that, or like?
Yeah, I'm not saying that it's a bad practice, but it kind of requires you to be careful on that, how you manage, because if I would set up a production environment for Kubernetes management cluster running Crossplane, at this point I would probably just do it with Terraform or any other tool and store the state somewhere and keep that as a more how to say, as a permanent platform where I build things on top of. So it might become confusing if you start to manage the cluster inside the same cluster. That's.
Yeah, I can imagine it might lead to like some deadlocks or something.
Yeah, and I mean, at least for me, it might be kind of conceptually difficult to grasp that what you're actually doing when you're managing the cluster that you're actually running the Crossplane in. But it's a nice way if you use a lot of automation and things like that. I don't see huge issues maybe there. If you combine something like Argo CD or Flux with it, could be nice.
But would you run it on like the same account on or project? What is it called in UpCloud? Or like entirely, maybe a different platform?
In terms of UpCloud, it really depends a lot on your use case. We have a lot of customers who use accounts and sub-accounts a lot, and others do not. So whatever fits your bill. But for me, it's always better to separate things in the best way you can. So it would be nice probably to run Crossplane cluster in a different account than the other services.
How about, is there like some GitOps model to this? So could I have like a repository for all of the infrastructure so that Crossplane then just observes that one, and if somebody pushes there a new file that's say like a resource definition, composite resource definition, it gets like added, and then the developers can push another file that creates the resource.
Yeah, that's exactly the workflow that would be feasible here. And Crossplane themselves provide documentation on how to do a similar setup that you mentioned with Argo CD. So that's maybe worth looking into. They have it on their site in the documentation section.
So hypothetically, I could even have it so if we had some like restrictions in the repository so that not anybody can approve pull requests to like the composite resource definition folder, then the developers could suggest that, hey, we want this kind of resource definition. Can you give me a thumbs up?
Exactly. So you could do everything in code instead of writing some requirements in any task management or issue tracker that you have, and then pass that on to the platform team, and then they have to decode it. But you could already do it in Git. Good idea.
How does it handle secrets? Let's say you create some database or something and you want to use it in an application, like mount the secret. Does the actual secret value ever go through Crossplane, or does it just pass reference around?
I left that part out from the examples, but there are kind of built-in references for secrets that you can pass around. So basically, it would be happening like that.
So nobody needs to see the actual value?
Yeah, exactly.
Awesome.
Yeah.
Okay, thank you, Ville.
Thank you.